Alright boys, today we're going to be learning the ionic bond route concept.
But coach, what's an ionic bond?
Well, you see, son, an ionic bond, specifically a binary one, is two elements, one metal, one non-metal. That's how we run it.
Well coach, how do we run that?
Well, you see here, son, there's more than one route to this route tree. Number one, we got representative. Then we're going to move on down to the polyatomic ions, and we're going to finish up with the transition. But remember, there's a little kick in the Roman numerals on that one, you know what I'm saying?
But coach, I already know how to do the representative elements. Like salt, otherwise known as sodium chloride, otherwise known as NaCl. I'll demonstrate this for you. Sodium has 1 electron in its outer energy shell, and chlorine has 7. In order for both of them to become stable, sodium will transfer its electron over to chlorine's, and that'll fill the outermost energy.
Alright, son, that's all fine and dandy, but what do you know about them polyatomic ions? Alright, you see, polyatomic ions are groups of atoms that are covalently bonded together, and they act as one single ion. Here's a bunch of them right here. Alright, so it bonds pretty similar to an ionic bond. Right here we got calcium and we got nitrate. They're going to come together right here to make calcium nitrate. You use parentheses so not to confuse these two as two different elements. They are actually one ion.
Alright coach, I think I got it.
Hold on now, son. You're forgetting about leg day. You forgot about the transition elements.
But I'm sure that's a lesson for another day, right?
Everybody back in. We're not finished yet. Alright, you see, for the transition element bonding, you gotta know about the oxidation level, which is the loss or gain of electrons. Alright, now like I said earlier, the big thing about the transition elements is you gotta use Roman numerals, alright? You see copper right here? It ebbs and flows between Cu plus and Cu2 plus right here. So you gotta either use Roman numeral number 1 or Roman numeral number 2. Oxygen stays at O2 minus. It'll just stay there. So when you're writing out copper oxide, you gotta put the Roman numeral to describe which copper you're talking about so you can write out the formula. So right here at A, we got copper, 1 oxide. So you got 2 coppers, 1 oxygen, Cu2O. B, you got copper, 2 oxide, CuO. That's it.
I think I got it, coach.
Green 18! Green 18 to go. Dun 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 dun.
Is that the Coach McElroy in action?
What?
You can always just cut out the side.
I'll just start now.
I have to be on this side. I have to be on this side.
You don't.